The quotient rule for square roots states that for any real numbers, square root of a and square root of b, with square root of b not equal to 0, that the quotient of two square roots is equal to the same as the square root of the quotient. This rule can be in either direction, and we'll illustrate that with this example here. We have the square root of a quotient, and going in the reverse direction, this is equivalent to the square root of the numerator over the square root of the denominator. Since each is a perfect square, we can simplify further with the square root of 4 being 2 and the square root of 9 being 3. In its original form, 4/9 was reduced to its lowest terms, but by applying this quotient rule, we were able to simplify this division involving square roots. Let's take a look at this next example. Again, as it states right here, the square root of 149, we can't simplify this rational expression. However, using the quotient rule in the reverse direction, it's equivalent to the square root of the numerator over the square root of the denominator. Square root of 1 is 1, square root of 49 is 7, and we've simplified this square root of this rational expression. Let's look at one additional problem. Square root of this quotient, it cannot be reduced, but if we break it into the square root of the numerator over the square root of the denominator, we are able to simplify. Square root of 16 is 4. Square root of x squared, or anything squared, is that quantity. And likewise, square root of y squared in the denominator is y. So the result of this division is 4x over y.